Hey guys, Zol here. Today I want to talk with you about the most dangerous chemical I have ever used as an undergraduate chemistry major. Now, just as a preface, I know there are a lot more dangerous chemicals that a lot of professional chemists and grad students have used, but usually as an undergrad chemistry major, in the grand scheme of things, you're not going to use some insanely dangerous chemicals like tert butyl lithium and stuff. And it's pretty tame stuff, so overall, this is the most dangerous chemical I've used. It's not something you would ever use in a normal undergraduate chemistry class's lab, but since I'm doing research outside of class and this is a lab filled with PhD students, we have to use a lot different chemicals and tool sets than are normally used in an undergraduate chemistry lab. And this is how I came to work with this chemical. This chemical can sear through flesh and completely destroy any biological matter or residue within literal seconds while violently boiling around. And it has an extremely high chance of explosion if not treated with the utmost care. What am I talking about? Piranha solution. The aptly named piranha solution can eat through nearly anything you can throw at it. It'll quickly oxidize metals and any biological matter, it'll just sear through it and go back to a clear solution. There are plenty of videos on YouTube that you can check out of people putting some crazy stuff inside piranha solution and just watch it instantly dissolve. Piranha solution is a mixture of very highly concentrated hydrogen peroxide and high concentrated sulfuric acid, making it both an extremely strong oxidizer and an extremely strong acid. This combines into something called Caro's acid, which will just eat through any organic matter. With piranha solution, the preparation of it is extremely exothermic, and this can be super dangerous because unlike a lot of other reactions, the stuff that's going to be boiling here will just eat through your flesh or any organic residue, or if it comes into contact with certain chemicals, can just explode. So you have to add it extremely slowly and extremely carefully, because if you add it too fast, the solution will instantly boil up everywhere, and you do not want this stuff on your hands or even your lab bench. The first time I did use this, one single drop got on the lab bench, and now there's a permanent dent where the solution started to eat through it. Piranha solution, when you're adding it together, can get up to 100 degrees Celsius, so you'll just have this boiling, corrosive, oxidizing agent splashing everywhere, and that's why it's imperative to handle it and prepare it super carefully. On top of this, peroxides, if you have old ones left out, can tend to become explosive when they've dried into white crystalline structures. So you have to make sure you use fresh reagents with your piranha preparation. Now, why use piranha solution if it's so dangerous? So piranha solution isn't usually a step in a reaction you're doing, and it's not usually something you do to add a bit to a chemical you're trying to make, but it's actually used as a cleaning agent. It's really useful for cleaning all organic residues off glassware. If you have something that's super stubborn or stuck onto it and literally nothing else works, or if you need some insanely clean glassware, you'll hit it with piranha. As they say, there is no clean like piranha clean. Now, of course, because piranha solution can explode if it comes into contact with the wrong things, you're going to want to pre-clean this glassware. You're going to want to do your normal soap, scrub it, sonicate it, whatever you can to get it clean before putting your piranha in. It's also really useful if you need to clean off sintered glassware, because stuff can really get into all those cracks in the glassware and it's almost impossible to clean off any other way. So if you have a stubborn chemical stuck in there, you might have to use piranha to get it out. On top of this, piranha is also used in the electronics industry extensively. For those of you that don't know, in the electronics industry, they'll have a silicon wafer, as it's called, and they add this photoresist, which is like a protective layer on the surface, so they can selectively dope certain parts of the silicon with a different element to create conductivity. And this is almost like when you're painting a wall of a room and you put painter's tape on it, but usually this is a lot more difficult to do than painter's tape and a lot harder to remove, because you're going to be putting it in with chemicals and you're going to have to dope it in like a high heat oven with that chemical. So what happens is a lot of the times after they dope the silicon, to clean off the photoresist, they will use piranha solution to just eat away at that photoresist and get an extremely clean sheet of silicon after doping. This is really important because the purity that they use for silicon in the electronics industry is insane, and it's almost like nothing else we use in the lab. Now, I was using piranha solution in my lab on silicone wafers like this, but it wasn't necessarily to clean off photoresist, but for the lab and the research that I'm doing, we needed an extremely clean surface on the silicon wafer, so we had to clean off everything we could and then piranha clean the silicon wafer before using it for our purposes. Now, if you're using piranha solution, you should always look for an easier path before using piranha because it is extremely dangerous. It can eat through so much stuff. It's a pain to prepare. You can't keep it stable for very long, so you have to prepare it fresh every time you want to use it. And one of the scariest parts about piranha solution is you're working in a chemistry lab, and chemistry labs tend to be filled with organic solvents. Stuff like acetone and all to clean glassware. The issue with piranha solution is if it comes into contact with an organic solvent, it'll blow up. You will create a bomb, and that is not good when your lab is generally filled with all sorts of those kinds of chemicals. You have to get a dedicated fume hood that doesn't have any organic solvents in it, and it's just an act of super careful preparation to make sure piranha doesn't come into contact with something that it's going to make it explode. I remember the first time I used it, I had to read through this email that the professor sent me with like data sheets and all, and I had a warning in the email saying, this should be relatively safe, but if you mess up, you could blow yourself and the lab up. So that's why piranha solution is by far the most difficult and most dangerous chemical I've ever worked with in a lab in my undergrad. And so if you have any super dangerous chemicals that you've gotten to work with in undergrad, be sure to let me know in the comments down below. And if you liked the video, let me know, drop a like, and I'll see you guys next time.